Welcome to Full Solar Eclipse, August 21st, 2017. In a few minutes before your very eyes, the sun will simply disappear from this beautiful summer midday sky. Or at least 87% of it will.
Behind me, which is a light source, pretending that it's the sun, and we have the Earth and we have the moon. So the moon actually travels in front of the Earth, covering the sun, and that's what causes the total solar eclipse. Did you see that shadow, Lily?
I did.
There it is.
So
basically that shadow creates what is called a path of totality, which will be a strip of darkness. This is not exactly to scale, but it is helpful to see. It's very simple. The shadow of the moon is cast upon the surface of the Earth. The moon is indeed much smaller than the sun. 400 of these little moons will actually cover the diameter of the sun. But the moon is also 400 times closer.
Directly behind the moon is a dark shadow called the umbra. When you're in the umbra, you cannot see any sunlight at all because the moon is directly blocking your field of vision. Watch as the Earth turns and the region covered by the umbra moves across the continent. This is the closest the umbra is ever going to get to us. You'll get good data from the umbra in Carbondale, Illinois, and in St. Louis. Here in Chicago, we're going to be in the penumbra, the indirect shadow, which, as you can see, is much bigger and covers the whole continent and most of the ocean, even as the Earth turns. In the penumbra, we will find the sun mostly blocked out by the moon's shadow, but a little sunlight from the edges will still reach us because we're not directly behind the moon.
Who else is going to be watching this eclipse with us?
Lika Guathakurta at NASA has the full map.
White patch that you see is actually the shadow of the moon. It is the penumbra. The wider range that you're seeing is this is the umbra and the rest are penumbra. And it is in this patch that you are going to be able to see a total solar eclipse when the entire bright disk of the sun is going to be covered by the moon. And this goes sort of coast to coast from west coast of Oregon all the way to South Carolina, crossing over 12 states within easy driving distance for at least 100 million people with 100 or more universities and colleges. It's a great opportunity, and I think this is going to be one of the most observed, filmed and photographed, studied and documented, and most appreciated eclipse. And everyone who can should go try to see this totality.
Great, thank you. I can't wait. So if an eclipse happens when the moon passes in front of the sun, why don't we see one every single month?
What a great question. The short answer is physics, celestial mechanics, math. So what happens is that the plane in which the Earth goes around the sun, called the ecliptic plane, is not the same as the plane in which the moon goes around the Earth. It's offset by about 5 degrees. These two planes have to coincide for us to see whether a total solar eclipse or a solar eclipse or a lunar eclipse.
Like this.
Whole viewing box. Take a box, something at least this big, preferably a little bit larger. Okay, you want to close it off completely. And then you want to cut 2 squares on the end. And over one of those squares, you want to put a piece of thick paper or even better yet, aluminum foil because you don't want any light to go through it. Then you take a thumbtack or a push pin, make a little hole. So now you've done that. So take this, point it down at the ground with the sun behind you so you can see your shadow in front of you. Then look through that open area and you'll see a little dot. And that is the sun projected onto the back.
Yeah, I see it.
Now, as your box gets bigger, you pick a bigger hole and you'll actually see a bigger sun projected on the back. But pretty nice way to do it.
So why do we care?
Eclipse chasing is a scientific profession. Astrophysicists fly around the world just for the chance to be in the umbra, if only for a few minutes. But a solar eclipse provides our only look at the layers of the sun that we usually can't see due to the bright white light from the core. Virtually everything we consider to be the sun, bright white light, ultraviolet, infrared that delivers heat, X-rays, gamma rays, everything that we see on this planet comes from the tremendous nuclear fusion factory in the sun's core. It whites out everything else in the convective zone, where hot gases transfer heat in and out of the nuclear fusion factory, and the photosphere, let alone the corona and the chromosphere. When a solar eclipse blocks out the bright white core, then for the first time we can actually see on Earth the coronal streamers. We can get a bird's eye view of the sunspots, of the granules in the photosphere, the little filaments chasing themselves around the sun's surface, and the tremendous magnetic and thermal activity that happens at our sun's surface. NASA physicist Eric Christian shows us the kind of activity they see on a coronagraph. You can see the inner area of the corona coated in orange and the outer area in blue. And when the white light from the core is blocked, we have a spectacular view of these magnetic disturbances, solar flares, massive coronal explosions that are happening on the surface of the sun.
The invention of the telescope, astronomers rushed to far-flung locations all over the world just to spend a few minutes observing, studying, and analyzing the mysterious corona. And it stayed that way until the technological leap that gave mankind the power to make its own eclipses. These artificial eclipses revealed something totally unexpected: eruptions in space that turned out to be the greatest exploding power grids. Coronal mass ejections, or CMEs, happen in the corona and are often linked to solar flares, which happen on the sun's surface. These are currently the most powerful explosions known in the solar system, approaching the power of 1 billion hydrogen bombs.
Coronal mass ejections involve so much mass and magnetic energy moving away from the sun. They can be as wide as almost half of the sun.
Here at Rochelle Zell, we're not in the business of making artificial eclipses by holding up a sun blocker to a computer screen. We're not tracking coronal mass ejections and solar explosions in a high school lab. So why do we care down here?
Hi, I'm Michael Doherty, co-president of QuarkNet. Where do cosmic rays come from? Frankly, we have no idea. But many of us at QuarkNet are building telescopes, cosmic ray telescopes, so we can see if they come from the sun during the August 21st eclipse. Join me on August 21st as we unravel this groundbreaking discovery in our lifetime.
Strange things. At one eclipse, we were in Bolivia, and we're all looking at the total eclipse when somebody shouts, "Look down, look down!" And we do, and we're surrounded by llamas. I don't know where they came from. When the eclipse was over, they all lined up in a line, and they marched away. At another total eclipse in the Galapagos, we were on a small boat, and 5 minutes before totality, every whale and dolphin in the vicinity, dozens, surfaced and swam back and forth and watched the eclipse with us. 5 minutes after totality, they all swam away, and we never saw them again.
Here's what we see in St. Louis or Carbondale or any other viewing station directly in the path of the umbra on a beautiful, bright, sunny total eclipse day. Our friends at Ida Crown, who are down at the ground there, are also viewing this with the special eclipse glasses that we're wearing to block out the sun's harmful UV rays. They are going to keep their glasses on for most of the eclipse, starting at 11:52 when the sky began to darken and the sun was partially blocked by the moon. They will get to see the spectacular diamond ring effect at 1 o'clock when the eclipse is almost ready to start. Bailey's beads, where we're seeing sunlight peeking through the valleys on the moon's topography, and the totality. We're here in Chicago where we're only going to get an 87% eclipse. Do not take off your eclipse glasses at any point, or you will do permanent damage to your eyes from the blinding UV that comes from the sun's core. Keep those eclipse glasses on, go outside, and watch the eclipse of a lifetime.